This is the first part of lesson 13.5, factoring trinomials. Okay, to start out, when we talk about factors, remember that a factor, we've used it as a noun, meaning a factor of something, and we've used it as a verb. So we've used it like when we factored out the GCF. And so just to review that whole idea, we're undoing multiplication when we factor something. So when we use it as a verb, what we're doing is we're undoing our multiplication. So the question, what do you multiply to get 12? You can do 1 times 12, 2 times 6, 3 times 4. Those are all factors of 12, but if I say factor 12, then you can say the factors are 1 and 12, 2 and 6, 3 and 4, not like 3 and 12. And so when we talk about what are the factors of 12, you can say 1 and 12, 3 and 4, 2 and 6, so they go together because they multiply together to give us 12. Okay, so let's take some binomials. So let's work this way where we multiply these binomials. So remember, distribute. So x times x is x squared, and then x times 5 is 5x, and then negative 2 times x is negative 2x, and then negative 2 times 5 is negative 10. And then we simplify that by saying x squared, and then these will go together, so plus 3x minus 10. And so that's our product of our two factors. So when we turn this question around and we say, what do you multiply in order to get x squared plus 3x minus 10? I'm asking, what are the factors of x squared plus 3x minus 10? So when I say, what are the factors, or what do you get to get that polynomial, you're going to say the factors are x minus 2 times x plus 5. Now, of course, you can say it in either order. You could say x plus 5 times x minus 2. That's the same thing. What's not the same thing is saying x plus 2 and x minus 5. Because if you switch those signs around, you're not going to get the same polynomial that we did the other way. So if you multiply this, you're going to get x squared minus 5x plus 2x minus 10, so there is a little difference there. And it's a big enough difference that it's not the same thing. So those are not the same, okay? So what we're going to do today is we're going to learn how to factor trinomials that do not have a GCF. When you're factoring trinomials, there are certain things that you need to ask yourself as you're doing these problems. And so the number one question is always, is there a GCF? That always needs to be the first thing that you look for, because if you forget to look for the GCF, it is highly likely that you can miss other things. So you want to always check for the GCF first. So that's even after we learn what I'm about to teach you, you always still want to check for the GCF first. Okay, the next thing, if there is a GCF, then you're going to factor it out. So same as we learned last time. So for example, if you have something like 3x plus 6, and there is a GCF, then you're going to factor that out. So that'll be factored, okay? Now what we're going to see today a lot is what if it's no? What if there is no GCF? So if there is no GCF, then you're going to factor it into two binomials if it's possible. Now sometimes it may not be possible. And so sometimes you have polynomials that just are not factorable. It's kind of like if you have 7, what can you factor to get 7? Well, 1 and 7, that's it. So we would call those prime. Now remember that we had something last time called the difference of squares. And I want you to remember about that, because if we have something like x squared minus 9, and I say to factor that, there's no GCF, okay? And so what mistake people make is they think, okay, well then it's not factorable. So remember that this one is factorable. It's a special pattern, and the way it factors is you take x plus 3 and x minus 3, and that will give you the x squared minus 9 because your middle terms cancel out. So I want you to remember that, because that's kind of like an exception to the rule of what we're going to be talking about today. So I just want you to remember that that's there. Okay, now remember, a number that only has factors of 1 in itself, like 7, is called prime. So a polynomial is not factorable if it only has factors of 1 and that polynomial, and so we also call that prime. When factoring a trinomial with a leading coefficient of 1, which is what we're going to focus on here, so a leading coefficient is the first number, so before the x squared. So if you have like 2x squared plus x minus 1, then that leading coefficient is a 2. If we just say x squared, then our leading coefficient is a 1. So that's what we're going to concentrate on today. And the strategy that I'm about to teach you will work when you have a leading coefficient of 1. We will talk at a later time about what you do if you do not have a leading coefficient of 1. So what you're going to do is you're going to ask yourself, what are the two numbers, or polynomials in this case, that when added together equal the middle term, and when multiplied together equal the last term? And so I'll show you what I mean by that. So they add together to be the middle term, and they multiply to be the last term. So just kind of as a preface to what we're going to do, if you were to multiply these two factors together, you get x squared, and then you get minus 4x plus 2x, and then minus 8. And so what I'm asking when I talk about the middle term here is when you combine those two like terms, you're getting the middle term of your final polynomial as negative 2x. And then the last term of your polynomial, this constant, how did I get that? I got it by multiplying those two numbers. So we add right here to get our middle term, and we multiply to get our last term. So that's what we're going to be talking about. Now I'm going to show you a strategy for how this works. We are going to use something called X games, and this is just a strategy. It's not like an official rule or anything like that. It's just a way to organize your thinking so that you can accomplish this goal. We're going to factor the polynomial x squared plus 3x plus 2. So what I'm asking you is I'm asking you what times what is going to give us that polynomial. So what we're going to do first is number one question, is there a GCF? So if you look at this, is there a number that's in common with all of them? So the answer to that is no. So always ask the question, even though sometimes the answer is going to be no, ask the question anyway, then you move on to the next question. So the next thing I want to know is what are the two numbers that when added together equal my middle term, so 3x, and multiplied equal my last term, or 2. And the signs here, the positive 3x, you don't have to write that, but just so you know it's positive, and then this plus 2. If that was a minus 2, you would have to write it, but we don't have to write it if it's positive. So that's what I'm looking for. I'm looking for is, do we have something like that? Okay, so what I'm going to do is I'm going to create this big X. And again, it's just a strategy to help me organize my thinking. And so I have this big X, and what happens is I'm going to put my middle term right there, and I've got a little plus sign indicating that we're going to add to get that middle term. And then I'm going to put my last term down here, and I've got an X to multiply, or to indicate that we're multiplying to get that term. So for this particular situation, I'm going to put 3x right here. Now, usually when I do this, I actually just don't worry about the X part of it. I'll just worry about the 3, and I'll add that on later. And then a 2 right there. And again, if it was negative, you'd have to put the sign. So the question, what two numbers can I add to get 3 and multiply to get 2? Well, this one's kind of easy, because how do you multiply to get 2? Well, you only have the option of 1 times 2. That's the only thing that you could do. And fortunately, they do add to be 3. So the answer is I can multiply 1 times 2. They will multiply to give me 2, and they will add to give me 3. So that works. It's just like a puzzle that you're solving. So now as far as what do I do with that, I'm going to use my factors of 1 and 2. And I'm going to put them into parentheses so that they look like factors that I would multiply to get my polynomial. So remember that my polynomial that I'm trying to get is x squared plus 3x plus 2. And so that's what I'm trying to get. So what I'm going to do first is I'm going to put x's right here. And then I'm going to use my 1 and my 2 right there. So then the big question mark is what goes in here? Is it a plus or is it a minus? And so there's a couple things that you can do to strategize with this. So first of all, if we're going to be adding to get a positive 3, you can't add negative 2 and negative 1 to get a positive 3. So that would tell me these are going to have to be positive. Also, if you do positive 1 times positive 2, you're going to get positive 2. So the signs work out there. Now, if you said, well, you can do negative 1 times negative 2 and get positive 2, you would be right, but you cannot add negative 1 and negative 2 and get positive 3. So as we do some other problems, we're going to talk about other patterns that we'll see, but that's how you're going to use this strategy. And so your answer for this question is right there. That is factored. So we're taking this polynomial, we're saying what is the factor, and then we're going to say those are the factors. That's what you multiply together to get x squared plus 3x plus 2. So let's go to another one. Okay, number 2, x squared plus x minus 30. So the first thing we're going to do is check to see is there a GCF. So is there a GCF? Look at the numbers. Those two right there, they don't have x's. There's nothing with 30, so I can just say no. Okay, so then the second thing is I'm going to look for, I'm going to look to do x games. So I'm going to make this x right here. In the middle, I'm going to put this term. Now that's a plus x, so that means plus 1. I'll just put a plus there just so that we don't forget about it. And then for the last term, I'm going to put negative 30. Okay. Now, when I look to see what goes here and what goes here, that's where the puzzle part of this comes in. That's where we have to strategize. So here's what we do. Look at 30. Ask yourself, what are ways that I can multiply to get 30? So I like to just list them. So 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Those are all the ways that you can get 30 when you multiply. So any of those would work right here. Okay, I could use any of those to get a multiplication or a product of negative 30. Now, as far as the negative part of the 30, we'll worry about that in a second. The next thing we need to do is we need to figure out how could I add those together to get a 1. So is there any way in this world that I could add 30 and 1 to get a 1? Obviously, if we add them together, you get 31. Well, what if they were both negative? Then you'd have negative 31. What if only one of them was negative? Then you'd have either 29 or negative 29. So this one's out. That's not going to work. What about 2 and 15? You could add them together to get 17, or if they were both negative, negative 17. What if one was positive and one was negative? Positive 2, negative 15, you get negative 13. Or the other way around, you could get positive 13. There's no way to get 1 out of that. With 3 and 10, I could get 13. I could get negative 13. If I had one positive, one negative, I could get a negative 7. And if I swap the signs, I could get a positive 7. No way to get a 1 out of that. With 5 and 6, I could get 11 or negative 11 if they were both positive or both negative. But what if I had one positive and one negative? So what if I had a negative 5 and a positive 6? If I add those together, I'm going to get a positive 1. That's what I want. So if I do negative 5 times negative 6, do I get negative 30? Yes, because I have one positive times a negative. Sorry, that should be a positive 6. So that's what's going to go right here. So negative 5 times positive 6. They add together to be 1, and they multiply to get negative 30. So then what I do is I'm going to say, all right, those are my factors. Well, those are part of the factors. And so to factor the polynomial, I'm going to factor it into x minus 5 and x plus 6. And that's my answer. Now, it does not matter if you say x plus 6 first and then x minus 5. It does matter that you get the signs right. So if you say x plus 5 and x minus 6, then that would be wrong, because that's not going to give you the right signs on your product. So what we're doing before, what we did was we started with this and we ended up with our polynomial. So we ended up with that. But now we're going the other way around. So we're starting with a polynomial and we're ending up with our factors. Okay, let's try another one. I want you to try this one by yourself and just kind of see where you get and see what your questions are, and then come back and see if I answer those questions or if you have more still. So look and see like what you're not understanding right now. Okay, the first thing you should have done, did you remember to check for a GCF? You need to get in the habit of just checking. It's a really quick process. You can just check really quickly to see that it does not have a GCF in this case, but you do need to make that quick little check. Then to do your x games, you're going to put a negative 9 on top because that's our middle term, and then 20 on the bottom because that's our last term. Now look for the ways that you multiply to get 20. So to get 20, I'm going to say 1 times 20, 2 times 10, or 4 times 5. Those are all the ways I can get 20. Now, if you say 5 times 4, that's the same thing. So I'm trying to get negative 9 out of that. So if you look at the possibilities, and I want you to look at this with me because I want you to see like how you're going to narrow it down once these get a little bit harder. If you have 1 and 20, you could get positive 21 or negative 21. If one was positive and one was negative, you could either get 19 or negative 19. So that's not going to work for us. 2 and 10, you could get 12, negative 12. You could get 8 or negative 8. Not going to work. 4 and 5, if I add those together, I can get 9. If they were both negative, that's how I'm going to get negative 9. If I had one positive and one negative, I'd have either 1 or negative 1. So I want the negative 9, so I need them to both be negative. So negative 4 times negative 5, do they multiply together to give me a positive 20? The answer is yes, they do. So that's what's going to go right there. And so your answer to the question of factor the polynomial is not the -4 and the -5. That's not the answer. You're not solving for x. You're not going to give me a single number. It's going to be factors. What do you multiply to get m squared minus 9m plus 20? So keep in mind we're doing m this time and not x. So you're going to say m minus 4, m minus 5. And that is your final answer. Now you can always check these questions. And so if you're doing this problem on a quiz or on a test, you can always check it by multiplying it through and just do the distribution and make sure that you're getting what you're supposed to get. And so that's just a good thing to know, that you can check this. You do not have to wonder or hope that you did this correctly. So since that's the same as what I started out with, I know that it's right, so I'm good to go. Okay, you go ahead and try number 4 and see if you do a little bit better on this one. Okay, you should have checked for a GCF. There is no GCF, so I'm going to put 3 right there and -40 right there. List your factors of 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8, and then it kind of repeats back, so 8 times 5 and 10 times 4, so we don't need to do anymore. I'm trying to get a sum of 3, so 40 and 1 are not going to do that. 2 and 20, not going to do that. 4 and 10, I could get 14, -14, 6 and -6, that's not going to do it. 5 and 8, if I add them, I could get 13 or -13 if they were both negative, but that's not what I want. But if one was positive and one was negative, so +5 and -8, that would give me -3. I don't want -3, I need +3. So I'm going to say, okay, well, what if I do -5 and +8? That's going to give me +3. So -5 and +8. Then your other job is just to check and make sure that they're going to multiply to give me -40, and they do. So I'm going to write my factors as p minus 5 times p plus 8, and that's my answer. So your answers now look like your questions used to. Okay, we're going to do a few more practice problems in this section. So number 5, go ahead and pause, do that, and then come back. There is no GCF on this. You've got to watch your signs on this one because you've got a lot of negatives. So we've already done the factors of 40, but I'll just repeat it so that we have them here. Okay, I'm looking to get -6 this time. So if you've kind of gone through these factors before, you kind of have an idea. I can use 4 and 10 because if one of those was positive and one was negative, so if I had a -4 and a +10, if I add them together, I'm going to get +6. So if I swap the signs and have +4 plus a -10, that's going to give me -6. That's what I want. So +4 and -10, they multiply to give me -40, so that's what I want. So I'm going to say +4 and c minus 10, that's my answer. Personally, I think factoring is kind of fun. It's just like a little puzzle that you're trying to solve. Once we know how to factor, we will learn how do we use factoring and what do we use it for. And so that's something that we'll learn a little bit later on. Okay, do 6 and 7. Once you've done both of those, come on back and see if you've got them right. Watch your signs. Okay, for number 6, I saw that there was no GCF, and so I looked at my numbers. I put -9 on top and -22 on the bottom. Looking at my factors of 22, 1 times 22, or 2 times 11. 2 times 11 was how I was going to get 9. So you mess with the signs and you make sure that you're going to get -9. So my -11 and +2. So I'm going to have w minus 11 and w plus 2. Okay, for number 7, there is no GCF, so I'm going to put a +1 right there and a -12 down here. So looking at my factors of 12, I've got 1 and 12, 2 and 6, 3 and 4. I'm trying to get a 1. And so 1 and 12 is not going to give me 1. 2 and 6 not going to give me 1. The 4 and the 3 could give me a 1, but I have to figure out how the signs are going to work. I know that since I'm going to get a negative product, one of those numbers has to be negative, either -3, +4, or -4, +3. So which one will give me a +1? So that's kind of the puzzle. So if I do -3 plus 4 or 3 plus -4, this one's the one that's going to give me a +1. So I'm going to have -3, +4. So when I write my factors, it's going to be in. Watch that. Some people like say, well, it doesn't really matter because it's just a letter. Like, yeah, but we're trying to solve a specific polynomial. And if you have x there instead of n, it actually doesn't give you this polynomial. It gives you the same polynomial, but with x. It's kind of like calling somebody by the wrong name, just not correct to do so. So anyway, just try to watch your letters there. Okay, the rest of this lesson will be continued in the next video.